Hello friends, today we are going to solve a equation based on the electrostatic potential or electric potential. First of all, we should know about the what is electric potential. Okay, I will going to tell you what is electric potential. If we have a 2 point, suppose let we have a 2 point that is plus q and q naught. This is a test positive charge, and this test positive charge we have to bring at this point. If this charge make a field, then this q naught will get attracted toward this side, and there is some work done. So this work done in bringing a charge from infinity, suppose this point at the infinity to the point. Okay, you understand this topic? What is electric potential? If you are bringing this q naught charge at this point, so total work done in bringing a charge from infinity to the point, from this point to this point, this is called a electrostatic potential or electric potential. Okay, we are joining this line. Suppose this is a q point and the length of this q point is dl. Okay, suppose we know force on the charge in electric field is denoted by F equals to q naught E. Okay, for balancing this force we need to apply a external forces. External force, that is, suppose this force is going this direction, then we should apply the external force, that is minus q naught E. Okay, to neutralize the effect of the forces or to make the charge static. Okay, now we know the distance between this point to this point is a, from this point O to P, that is R. Okay, now we have to find what is the work done on bringing this q naught charge to the point plus q. Okay, now we are solving the equation for this derivation. Okay, first of all I will tell you what is a potential here. Suppose we are bringing the charge from infinity. Okay, so value of infinity get 0, so we have w work infinity to point A, and this is a q naught charge. This q naught charge we are bringing from infinity to the point. This is the first equation. Okay, you understand this? Now I will tell you what is the work done here. Okay, so what is the work done? Work done equals to F dot dl. Okay, this work done is FDL. Okay, we know what is the force. Force is minus q naught E. This is the external force. Now we are placing the value of F from this to this equation. Okay, then the equation became q naught E dl dw. Okay, now we place the value of the electric field. We have learned about the electric field due to a point charge is 1 upon 4 pi epsilon naught q upon r square. So we are placing this value of E 1 upon 4 pi epsilon naught. So we are placing the value of E, that is 1 upon 4 pi epsilon naught q upon r square and dl. Okay, now we know the value of r is decreasing along this length. Okay, so we can write this dl 1 upon 4 pi epsilon naught q upon r square minus dr, because the dl is decreasing in the direction of dr. Okay, so we have the equation that is 1 upon 4 pi epsilon naught q naught r square and dr. Okay, one thing is that important, that we should also do we have to also break the force in the cos angle. Okay, we have FDL, then FDL equals to F dot dl cos 180, and the value of 180 is -1, that is equal to f dot dl. Okay, then this f dot dl, when we place this value of f here, then it is become a positive. Okay, you understand this topic? Don't be confused, the minus sign of f. Okay, then minus minus becomes plus. Okay, minus of q naught e, that is this. Okay, you understand this point? Okay, you understand this, what I mean? The value of f dot dl cos 180, that is equals to minus f dot dl. When you place the value of f, that is minus qe, then minus minus get plus. Okay, so we are writing plus on this equations, plus, and now the sign of the minus dr comes in the front. Okay, I am writing this equation for you in the bottom, that is minus 1 upon 4 pi epsilon naught q naught upon r square and dr. Okay, you understand this? Now we have to integrate this. Okay, we should integrate this from, we are bringing a charge from infinity to the point, so we are doing a integration infinity to point. Okay, you are getting this point? Okay, now I'm moving on the next page. Okay, now we are moving in the next page. Now we are integrating the value of dw dot 1 upon 4 pi epsilon naught q naught upon r square dr in minus. We are going to integrate that, the infinity from the point A and infinity from the point A. Okay, now listen this topic very clearly. Now 1 upon 4 pi epsilon naught q naught from infinity to the point 1 upon r square, we are going to integrate. Okay, and the value of dw is from infinity to the point A. We can write this. Now 1 upon 4 pi epsilon naught q naught, this value of r goes upside, that is equals to r minus, that becomes r minus 2. Okay, now we are going to integrate this. 1 upon 4 pi epsilon naught q naught, and this is r the power 2 minus 1 and minus 2 plus 1. We are taking the limit from infinity to the point A, and 1 upon 4 pi epsilon naught q naught r minus 1 and minus 1. This equation becomes like this. Okay, now what we are going to solve, that is for the limit. Okay, watch this carefully, this is a very important topic for the class 12 students, and lot of question is asked from this topic. So we are placing the limit, this become 1 upon r infinity to the point A. Now 1 upon 4 pi epsilon naught q naught, from upper limit we are going to put minus lower limit. Okay, so 1 upon 4 pi epsilon naught q naught becomes minus 1 upon ra. Okay, this value becomes 0. Okay, this value becomes 0. Now this becomes 1 upon 4 pi epsilon naught q naught has w infinity to a. Now q naught goes in the bottom of this, and 1 upon 4 pi epsilon naught q, this value I will tell you in the first equation what is the value of this. This value is va, so we are placing this point here, we are getting this value. So this is the equation for electric potential due to a point charge. It is a very important equation. You you need to revise it, and you can comment also, like this video. Whatever problem you have, you can ask me in the comment. And thank you for watching my video, and share as much as possible. Thank you.